Welcome everyone. We are discussing derivatives. Through this video, I will discuss today some important problem of derivatives. So, look problem number 1. The value of ddx of tan square 3x minus tan square x divided by 1 minus tan square 3x into tan square x whole into cot 3x. So, derivative of this part. So, y equals to now before simplifying derivative we have already discussed. We try to simplify y if possible. So, we simplify it. So, a square minus b square, a plus b, a minus b, a plus b, a minus b into cot 3x. Now, tan 3x plus tan x by 1 minus well known formula tan a plus b. Then tan 3x minus tan x by 1 plus tan 3x into tan x into cot 3x. So, this is tan a plus b. So, tan a plus so this is tan a plus b. I think this is tan square 2x. Tan square 2x. I think this is tan square 2x. So you simply correct it. So this is tan square 2x. 2x. So tan 2x. This is tan 2x. This is 2x. This is 2x. This is 2x. This is also 2x. Now, tan a plus b, tan 2x plus x. So, this is tan 3x. This is tan x, tan a minus b. And this is cot 3x. So, cot 3x, tan 3x cancel out. That is why we are changing this 3x. Otherwise, it will be 4x. But this is cot 3x. Now, y equals to tan 3x. So, what is dy dx? Dy dx is sec square x. So, C is possible answer. So, before simplifying, you must simplify it if possible. Call this as y and simplify. So, actually, it is problem of trigonometry. Next, second one. F dash x equals to sin log x, y equals to function of 2x plus 3 by 3 minus 2x. Find dy dx at x equals to 1. So, y equals to f of 2x plus 3 by 3 minus 2x. Now, what is dy dx? Function of function f dash 2x plus 3 by 3 minus 2x into ddx of this argument. Omitting one step, 3 minus 2x whole square, 3 minus 2x into minus 2x plus 3 unchanged into minus into. Now look, f dash x equals to sin log x. So what is f dash 2x plus 3? So f dash 2x plus 3 by 3 minus 2x. So x is replaced by this argument. So what is f dash? So this is sine log unchanged. X is replaced by 2x plus 3 by 3 minus 2x. So this is value of f dash x. It comes from this f dash x is given, x is replaced by this. Now this is 3 minus 2x. So 2 common. 3 minus 2x plus 2x plus 3. So 2x, 2x cancel. Now dy dx. So this is dy dx. But you have to find dy dx. You have to find dy dx at x equals to 1. So sine log. So 5 by 1. So log 5. Log 5. This is 3 minus 2. This is 1 and 6. This is 12. So final answer is 12 log 12 sine log 5. 12 sine log 5. So it is very simple. Y is given, dy dx equals to f dash this, then dx of I. Now f dash is given. Otherwise, answer will be in terms of f dash. Now we consider two important problems. They are also typical problems. Problem number 3 and 4. So consider problem number 4. Y equals to tan inverse 1 by 1 plus x plus x square. Tan inverse x square plus 3x plus 2. Tan inverse x square plus 5x plus 7 up to everyone. Find y dash 0. So now nth term is not given. So you have to find nth term. Now what is T1? Actually it is problem of inverse circular. This is T1. Now, so you look tan inverse x minus tan inverse y plus minus. Tan inverse x plus y 1 minus 1. So this is plus minus, this is minus. So T1, this is given in compact form. Our main aim is to write each term as a difference of two terms. So write this one is x common. Now this one is tan inverse x plus 1 minus x. So 1 plus. So this is tan inverse x plus 1 minus tan inverse. So this is T1. So this is our main aim. Try to write this relation as a difference of two terms. So why I am discussing it later. Now y equals to tan inverse 1 by x square plus 3x plus 2. So tan inverse one by 1 plus x square plus 3x plus now this one is, you correct it, x square plus 3x plus 3. This one is plus 3. So this is plus 3. So we can write it this. So tan inverse 1 by 1 plus, this is if we factorize x plus 2, x plus 1. So this one can be written as x plus 2 minus x plus 1 by 1 plus 2, x plus 2, x plus 1. So this is most important step. So this is x plus 2 minus tan inverse x plus 1. So this is second term. This is T2, not y. This is T2. Similarly T3. This is 1 plus x square plus 5x plus 6. So if we use this step, T3 will be tan inverse x plus 3 minus tan inverse x plus 1. So if it is 2, then it is 1. If it is 1, then it is x. So if we simplify, now look. So what is first term? So this is tan inverse x plus 1 minus tan inverse x. This is tan inverse x plus 2 minus tan inverse x plus 1. This is second term, that is y x plus 2. Third term, tan inverse x plus 3 minus tan inverse x plus 2. We will complete it. And what is nth term? Nth term is tan inverse. If it is 2x plus 2, it is third term x plus 3. So this is x plus n minus tan inverse x plus n minus 1. Now look, x plus 1, this one is cancelled out. X plus 2, x plus 2 is cancelled out. Here there is a term, so this negative term is also cancelled out. If you write the previous one, then this term will be cancelled out. So we are living with two terms, tan inverse x plus 1 minus tan inverse x. So actually it is problem of inverse circular function. So this is simplified form. So what is dy dx? 1 by 1 plus x square. This is 1 by 1 plus x square. Derivative of tan inverse x. This is x. Now you have to find y dash to 1. So dy dx at x equals to 1. Find y dash 0 at x equals to 0. So 1 by 1 plus n square minus 1. So 1 plus n square, x is replaced by 0. So 1 plus n square is LCM 1 minus 1 minus n square. So minus n square by 1 plus n square. So this is actually problem of inverse circular function. Y equals to this. So T1, T2, Tn, all terms will be cancelled out. We are living with two terms. You have already solved this problem in terms of if it is y, what is y infinity. Next, problem number 3. So y equals to fx equals to this, find f dash 2. Now I am repeatedly saying, so y is given in this form, you simplify first, then try to take differences. So fx equals to log tan x by log cot x, and this is log cot x by log tan x whole to the power minus 1. This is tan inverse. So, look, this is given in compact form. Divide by 4. 1 minus x by 2 whole square. This is x. So, to make it 1, divide by 4. Now, log tan x, log cot x, and tan x will be at the numerator, log tan x, log cot x, inverse, that is 1 by a. So, this is tan inverse, 2 into x by 2, 1 minus x by 2 whole square. So, log tan x whole square, log cot x whole square, 2 tan inverse x by 2. This is simplified form. Now look, you cannot take 2 here because total whole square. So this is fx. Now you find f dash x. So what is f dash x? So use quotient rule. Log cot x whole to the power 4. Log cot x whole square unchanged. 2 log tan x. 1, 2 come forward, power diminished by 1. Then derivative of tan x. Log tan x, 1 by tan x into sec square x. Minus now listen again. Log cot x, cosine whole to the power 4. Log cot x whole square unchanged. 2 log tan x, 1 by tan x sec square. Minus log tan x whole square unchanged. 2 log cot x into 1 by cot x into cosec square x with negative. So this is plus. So this is derivative of this part. This one is 2 unchanged. 1 plus x square by 4 ddx of x by 2 is half. Is half. 2 unchanged. 1 plus x square by 4 into half. So this is differentiation. Now it will be simplified if we put x equals to, so find f dash 2. Find f dash 2. Log tan x, log cot x, log cot x, log tan x whole to the power minus 1. So f dash 2. Actually, it is tan x. So cot 2. 2 means 2 radii. So this is f dash x. Now if we take f dash 2, f dash 2x is replaced by 2. So we are not getting any simplified form because cot 2 and tan 2, these are not simplified form. So look, if we calculate, it is f dash pi by 4, then it will be simple because log cot pi by 4. Log cot pi by 4 is 1. This one is 0. So f dash 2. You calculate f dash 2. So write log cot 2 whole to the power 4. Log cot 2 whole square. 2 log cot 2, and this is sec square x, 1 by cos square x, cos x by sin x, 1 by cos square x, cos x by sin x. So 1 by tan 2 into sec square 2 plus log tan 2 whole square, 2 log cot 2 into cosec square 2 by cot 2 by log cot 2 whole to the power 4, and second one 1 by 1 plus 1. So this is half. Second part is half. Now so this part will be simplified and you get a result. But look, this is log tan x log cot x into, if it is of this form, fx equals to log tan x cot x, log cot x into tan x, then it will be log tan x by log cot x. This is log cot x by log tan x. So if we simplify, this is 1. So fx equals to 1. So if it is 1, then derivative of, and second part is 2 tan inverse x by 2. So 2 tan inverse x by 2. 2 tan inverse x by 2. So what is f dash x? 0 plus 2 into 1 plus x square by 4 into half. So what is f dash 2? F dash 2 is half. So to our answer here, answer is given that it is half. So if answer is half, then this minus will be cancelled out, because you are not getting any simplified form by putting x equals to 2. So I think this is a log cot x by log tan x. There is a problem of IIT also. Problem is given in this form here. This is log tan x log cot x whole to the power minus 1. Then f dash pi by 4 equals to 1. Then it is 40. But if answer is half, then this inverse is not present. Now we consider 3 similar like problems. F tan x to f cot x equals to x sin f dash x. Fx plus f1 minus x tan inverse x sin f dash 1. If 3fx 2f1 by x equals to x sin f dash 2. So these are problem of functional relation. So we have already discussed this type of problem in derivative of functional relation. Now look, they are of same type. So our main aim is to find fx from functional relation. So consider problem number 5. Problem number 6 is simple. Look, your main aim is to find x. So you have to replace x by 1 minus x. Here in 11, x by 1 minus x. Now problem number 5. So fx is given. Now x, changing x, our main aim will be to get functional relation involving tan x and cot x. So if we change x by pi by 2 minus x, so what we are getting? F tan pi by 2 minus x, 2x cot pi by 2 minus x equals to pi by 2 minus x. So f cot x, 2f tan x equals to pi by 2 minus x. So this is 2. So f tan x. Now we have to find first f tan x or f cot x. So f tan x. So multiply 1 by 2. So 2f tan x plus 4f cot x equals to 2x. And this is 2f tan x, f cot x equals to pi by 2 minus x. So tan x is cancelled out. 3f of cot x equals to what? Pi by 2 minus x, then this is plus. So we are getting 3x plus pi by 2, 3x minus pi by 2, 3x minus pi by 2. So what is f cot x? X minus pi by 6 dividing by 6. Now what is our main aim? Our main aim is to get fx. So cot inverse cot x is 1. So replacing x by cot inverse x. So what we are getting? F cot inverse x equals to cot inverse x minus pi by 6. So fx equals to cot inverse x minus pi by 6. We suppose that x is in principal value, x belongs to principal value. That is why cot inverse cot x is x. Now what is f dash x? F dash x is 1 by 1 plus x square with sum, and derivative of pi by 2 is 0. So this is f dash x. So 6 and 11 they are of same type. Find fx, then perform derivative. So this is most important problem of IIT. Next we consider different type of problem. I consider 3 more problems, 8, 9, 14. So problem number 8. So y equals to sine inverse. So root x into 1 minus x common. So root a into 1 minus x. So this is sine inverse. Now derivative of sine inverse is 1 by root over 1 minus x square into dx of alpha. So that is why it is not easy to find derivative using direct formula. So we try to express it into simple form by using formula. Now look, you know sine inverse x minus sine inverse x into root under 1 minus y into root under 1 minus x square. So We have already discussed it. Problems in terms of tan. Given in compact form, you have to write as a difference of two terms. So this is given in compact form. So look, sine inverse root x. This is x and this is y. So 1 minus root a whole square. And you can simplify it. Root a 1 minus root x whole square. So look, 1 minus a. So this is, you can write it in this form. Now x, sine inverse x. X is replaced by root x and y is replaced by root x. So this is sine inverse root x minus sine inverse root x. So this is simplified form. Now look, it is compact form. Now look, sine inverse x minus sine inverse y. Root x into 1 minus root a whole square. That is 1 minus a root a into x. So this is simplified form. Now dy by dx. Now it is very simple. Root over 1 minus x root x whole square ddx of root x is 2x. And this one is constant. If it is not given, what is a? Other than x and y, we treat it as a constant. So this is 0. So this is value of dy dx. So for solving problem of inverse circular function, we must simplify at the beginning if possible. Next, second one, exactly same problem, 14. So y equals to cot inverse a minus b plus x by 1 minus x into a minus. Now this is tan inverse. Formula of tan is simple. So this is 1 minus. So tan inverse 1 minus. So this is not form of tan. So look, we can write also in terms of tan. So pi by 2 minus tan inverse a minus b plus x 1 minus x into a minus cot inverse x, pi by 2 minus tan inverse x. Why we are writing it in this form? Because look, this form is direct form of tan inverse, compact form. This is x, this is y. So a minus b, so pi by 2 minus tan inverse a minus b plus tan inverse x. So look again, tan inverse x plus y, tan inverse x plus tan inverse y, x plus y 1 minus xy. Now this is simplified form. So if we write it, cot inverse x equals to tan inverse 1 by x, then tan inverse form, this is x plus y by 1 minus xy. So it is not of this form. That is why we are writing this in terms of tan inverse. Now dy by dx. So this is 0, this is 0. So 1 by 1 plus x square and negative at the beginning. Negative at the beginning. These are most interesting problem and important also for board and competitive exam. Now problem number 14. Sin inverse x square minus y square by x square plus y square equals to log. Then dy dx equals to this. Look, dy dx is independent of constant. Independent of constant. So look, we can write it as x square minus y square by x square plus y square sine log x. So this is constant equals to c say. This is constant. Now we can simplify it by using component and dividend rule. So look, x square plus y square minus x square minus y square. So x square plus y square plus x square minus y square. So 1 minus c by 1 plus c. Dividend and component. So what advantage you are getting? Y square by x square. 1 minus c by 1 plus c. So finally we are getting y 1 minus c 1 plus c root over plus minus. So this is simplified form. Now y equals to this into x. If we find dy dx, then dy dx equals to root over 1 minus c by 1 plus c, where c equals to sine log k. But here c is not given. So to get a result, so differentiate independent of c. So cosine root x square, x unchanged dy dx minus y unchanged 1 equals to 0 because it is constant. So dy by dx equals to y by dx. So y by x is answer. So sine inverse. So look at the problem. So it is independent of c. So transfer right hand side, then use component and dividend. You can also any correct method, but you should look whether method is simple or not. So through this video, I have discussed solution of some important problem of derivative. So you solve the rest of the problem from the description table. Thank you for today.